So in this video, I'm going to be talking about differentiation by first principles, what it means, how it's used, and how to apply it to a problem question. So first off, what is it? Its formula is given by the first derivative of the function f of x is equal to the limit as some small change in x approaches 0 of the original function plus the small change, take away the original function, all divided by the small change delta x. So what does this mean? So clearly you can't just input delta x equals 0 into this equation, because if you did that, what you would be left with would be f of x minus itself divided by nothing, which equals 0 over 0, which is mathematically undefined. So we need to do some more work to find out what happens when we have a very, very small change in x. So if you think back to your days in school, you might remember how to get the formula for a line graph of which you don't know the equation. So a standard straight line, the formula is given by y equals mx plus c, where m is the gradient of the line and c is the y-intercept of the line. So if we say that's 0, in this instance, and this point here is given by, for example, 10, and this point here is given by, for example, 5, we know that the change in y over the change in x, which is sometimes called rise over run in school, is equal to 5 over 10. Very simple. So it's a half. So we know that the equation for this line is y equals a half x plus 0. So what differentiation by first principles is trying to do, and all differentiation for that fact, is attempting to get the area of an infinitesimally small slice of this triangle and being able to explain what happens to y. And that's given by dy by dx. And it comes from this. So it was originally called delta y by delta x. Mathematicians just got a bit lazy and dropped the Greek alphabet. So how do we calculate it, you might be asking? So in the next video, we're going to look at how we can use algebra in order to solve this equation and find out what happens at the smallest possible change in x.